Hello, my name is Keshwani. There's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 174. Page 174, today is our lesson number 175, and the problem that we are about to solve is number 159. In problem 159, we are given a trapezoid which looks something like this, and we simply asked to find the area of it. That's all it is. We just have to find the area, and the trapezoid looks something like this. This is the distance they're calling A to B. A to B. We are told is 13. We are told that this side is 2. And what else we are told? And we are told that the other side is 5. This side right here is 5. Listen. Okay? That is 5. And we are told this A to B is 13. The very first thing we want to do, is to be able to find this bottom here. Just use it, and this is a right angle triangle, obviously. They tell you that this is a right angle triangle, but there's a small symbol there. So let's look at triangle AB, and let's give it a name here. Let's call it A. That's the B. So A, C. Let's not introduce that complication right now. Let's look at ABC. Triangle ABC. In triangle ABC, we have A to C is our unknown, B to C is 5, and A to B we are told is 13. So this base is what we're trying to figure out here. All we have to do is a simple application of Pythagorean theorem, and it will find the base. It's simply x squared plus 5 squared equals 13 squared, which means x squared equals 13 squared, which is 169, minus a 25, which is 144, and therefore x equals 12. This is one of the familiar triangles that you should be that you should have acquaintance with. It is called a 5, 12, 13 triangle. There is one more triangle that you should be familiar with in the exam, which is called a 3, 4, 5 triangle, which is a more common one. A 3, 4, 5 triangle and a 5, 12, 13 triangle, it pays to have familiarity with. A 3, 4, 5 triangle is something, where can I write it? A 3, 4, 5 triangle, 3, 4, 5 triangle is something that you will find on day 7 geometry for GMAT. And the 5, 12, 13, 5, 12, 13 triangle is something that you will find at day 6. If you're one of those people who is a little rusty on geometry, if there are some concepts in geometry that you no longer remember because you learned them many moons ago, then you will find it helpful, perhaps fruitful, to watch these videos. Just type in this tag, geometry for GMAT, day 7, and similarly day number 6, and you will learn this concept of 3, 4, 5 triangle and the 5, 12, 13 triangles. Especially a 3, 4, 5 triangle. A 3, 4, 5 triangle, it doesn't actually appear as a 3, 4, 5 triangle. 3, 4, 5 triangle, if it does appear in the exam, most of the time it appears incognito. This one is not incognito, it's right there. If we had known a 5, 12, 13 triangle, we would have known right away that since hypotenuse is 13 and this side is 5, this has to be 12. It just saves us a few seconds. That's all it is. It's nothing earth-shattering here. You understand? It just buys you a few extra seconds, because otherwise we wouldn't have had to do it out. We would have known right away that it's 12. But it is 12. X squared plus 5 squared is equal to 13 squared, because it's the hypotenuse, and therefore x squared is 13 squared, which is 169, minus 5 squared, which is 25, and 169 minus 25. If you do it out, you will see that it is 144, and therefore x is 12. So that's right there. And we need to find out the area of the trapezoid. That's what we're being asked here. So let's find the area. We're done with this part here. Let's erase this thing. Now we're going to break it up into two parts. Let's look at this rectangle first. This rectangle here. Let's call it A, B, C. Let's call it D and E. So in the rectangle AD, ADEC, this side A to D, the area of the rectangle ADEC is AD times the bit, either DE or AB, or AC rather. And A to D is 2, A to C we just found out is 12, therefore it is 24. And now let's find out the area of triangle DBE. DBE, the area is 1/2, base is 12, same as this guy, AC and DE, same thing, is 12, times the height. How much is the height of the triangle DBE? Well, that's very straightforward. A to D is 2, which means E to C is 2. And since the total distance is 5, the height of this triangle that we're looking at must be 3. 2 goes into 12 6 times, and 3 times 6 is 18. And therefore the total area is 24 plus 18 is 42. In other words, we were looking for the area of the trapezoid, and we achieved it by chopping it up into two parts, into a bottom rectangle and a top triangle. And that's all it is. Let's do the next one, shall we? Let's do 160. We're done with this one. Allow me to sit for a second. Problem number 160. Don't forget the geometry videos that I told you about. They are at my channel, and you will find some concepts that you will need for the exams. There are many geometry concepts that we don't use obviously in our daily day-to-day routine, and we tend to forget them obviously. Number 160. We are told that xn equals 2 times xn minus 1 minus a half times xn minus 2 for all n greater than or equal to 2. Let's first understand what this says here. It's a series. It's a series, and this thing, what we just wrote down, gives us the formula of how we go about generating the next item in the series. So if you want to figure out, for example, if you want to figure out what is the second term in the series, so now n equals 2. If n equals 2, then second term in the series, this is how we will generate it. Second term in the series. So wherever we see n, we replace it with 2, because n equals 2. So wherever we see n here, we're going to have to replace it with 2. x2, x subscript 2, which means the second term in the series equals 2 times x to the 2 minus 1. 2 minus 1 is just 1. Minus a half, and then x to the 2 minus 2, which is same as 2 times x2 minus 1 is 1, minus a half times x0. But we don't have the value of the first term x1 and x0, do we? Yes, we do. They tell us that. What's the value of x1, we are told, equals 2, and x0 we are told, this is red. I just read it as x0 because I didn't want to introduce complication in the middle of my discussion, middle of my explanation here. But this is appropriate way to read this thing. It's not x0, but it is read as x0. Not as in cipher or 0. That's just a fancy way of saying x0. And that we are told equals 3. So let's put that in here. That goes here. x0 is 3. x1 we are told is 2. Let's put it in here. So 2 times x1, which is 2, minus a half times x0, which we are told is 3. Half of 3 halves, that's 1.5. So it's 4 minus 1.5, that's just 2.5. That's it, that's your answer, 2.5. And that's answer choice A. There you go, that's it. Or is it? No, answer is not A. Answer is not A. Answer is A for those people who are not paying attention, including myself. When I did this problem, I wasn't paying attention. I wasn't being attentive. They're not asking us what's the value of the x2. They're asking us what's the value of x3. We have one more step to go. This is the wrong answer. This is the x2. They're looking for the value of x3. We have one more step to go. x3 would equal, same exact formula, nothing changes. The same exact formula that we're going to use. 2 times x3 would be 3 minus 1 minus a half times 3 minus 2. x3 minus 2, which is same as 2 times x3 minus 1 is just 2 minus a half times 3 minus 2 is 1. So we just found the value of x2, which is 2.5. x2 is 2.5. We have to put it in here. 2 times 2.5 minus a half times x1, which we were given long time ago, which was 2. Well, 2 times 2.5 is just 5. And then these two cancel out and it's just minus 1, which is 4. And that's your x3. x3 equals 4, not 2.5. 2.5 was x2. And that is answer choice C. The answer is C, not A. A is the wrong answer. A is the sucker answer. For those people, as I said, who are not paying attention. I'll see you tomorrow, okay? Bye now.